Exchange high availability, public folders, and non-mailbox servers. So this is part 2 of our two-part series on high availability for Exchange 2010. And in this second half, we're going to focus just a little bit on some of the, well, let's call them less interesting servers, your non-mailbox servers in your environment. And I call them less interesting, not because, well, they're less interesting, they're just as important as those mailbox servers, and without them, the mailbox servers can't function. But they don't really have as much data, as much critical data on them, and in some cases have no data that you really have to worry about. And so, consequently, the process that you will go through for actually creating high availability out of these is somewhat easier than all the steps we had to go through in that last nugget. In this nugget, we're going to talk about how you can go through configuring that HA for things like the client access servers, for hub transport servers, and edge transport servers. I'm going to spend just a little bit of time talking about network load balancing, but really too much of a detail in network load balancing is out of the scope of this series. But at least you'll get an understanding of how you can implement network load balancing for creating arrays of servers that will support it. Also in this nugget, we're going to talk about configuring public folders for high availability. Now, when we go through the process of creating those database availability groups, really they don't provide the same sort of functionality for what we think of as our public folders. And so we need to create public folder replicas of the data that is out there and schedule that replication and then ultimately refer our clients to the proper public folder database so that they can have access to the necessary public folders that they're interested in. And in this nugget, we'll talk about that process of creating those that high availability for public folders. The first step here, however, is to really get a sense for the different types of high availability features that you can add into your environment even after you've gone through the trouble of creating those database availability groups. Now, if you think about the entire organization that you have, you're going to have obviously client access servers. And if you lose a client access server, that client access server is going to, or you're not going to be able to have your users connecting into your environment. If you lose a hub transport server, you're going to have problems with routing mail. If you lose that edge transport server, you're going to have problems with getting mail out to the internet and receiving mail from the internet. So a lot of organizations see the need for high availability, especially as the size of the organization goes up. Now, really, these servers, for the most part, don't have a lot of state data on them. And so creating things like network load balancing clusters is a really smart idea for creating an array of client access servers because it provides a mechanism for pointing whatever location, whatever client needs to be pointed to into the array, and then ultimately pointing them further on down into the correct mailbox server. So you'll find that when you're working with client access servers and creating high availability, the suggestion is to use a solution like network load balancing, or preferably a third-party load balancing solution for creating that client access server array. The same thing goes for down here for edge transport servers. You can use Windows Network Load Balancing or even a third-party load balancing solution for creating an array of edge transport servers. Alternatively, you can create round-robin DNS by adding in multiple MX records for those edge transport servers in your organization. Now, when you do this, when you create round-robin DNS records, you are potentially going to create a situation where you have round-robining and the server is simply not available. So you have to be conscious about the way that you go about actually configuring round-robin and put prioritization on those round-robin records as you're going through the process so that you have not only high availability, but the ability to survive a single failure of an edge transport server. Now, when it comes to network load balancing, the network load balancing service has been around for a long period of time. I've actually installed it to this server, but we're not actually going to create a network load balancing cluster. Here, if we take a look at the Network Load Balancing Manager, it's actually fairly easy to create a new cluster by right-clicking here and choosing New Cluster. Let's say that we want to connect to one host that's going to be part of this new cluster. And we'll just call it EX1 Nugget just for the purposes of seeing this wizard as it goes from start to finish. If we click the Connect button here, you'll see that there are a number of different interfaces that we can use for configuring that new cluster. And then we can choose which IP address we want to use as the dedicated IP address for this cluster. I'm going to choose 0.201, for example. We can choose what the default state is for the host. Is it started, stopped, or suspended? And do we want to retain the suspended state after the computer restarts? What this allows us to do is, if the computer experiences a problem or has to be restarted, do we want to bring it back into the network load balancing cluster or not by starting the host state, or starting the service more or less? If we click the next button here, we then need to create a cluster IP address, which, just like a regular traditional Windows failover cluster, it provides us a single IP address that we can then use to identify the cluster as opposed to the individual cluster members. Let's say we choose 0.212 here, for example, and a standard 24-bit subnet mask. This will then become the IP address that you should instruct your users to work with, because this IP address will be routed by the network load balancing cluster to the appropriate server based off of who has actually survived and who is actually up at the time that the client makes the request. If I choose the next button again, I can choose some more information about that cluster IP configuration, including providing a full internet name, perhaps NLB nugget.nuggetlab.com, for example. I can choose if I want to use unicast or multicast mode for cluster operation, as well as IGMP multicast. The determination here will be based off of your network characteristics and also the network security policies that you have. You may choose unicast because unicast provides an initial starting point, and maybe move to one of the more multicast modes later on down the road. If we choose the next button here, we can set some port rules for the inbound addresses and how we want to handle those clients as they're coming in. What sorts of protocols, for example, do we want to support for this NLB cluster? What sort of port range for those clusters or for those protocols do we want to support as well? And also, for those inbound clients, how do we want to set which of the cluster hosts we're going to send them to? Do we want to send them through multiple hosts? Do we want to set an affinity to them so that we know that the same client is always going to be going to the same ultimate endpoint as one of the NLB hosts? We can do that here. Or we can just set a single host or even disable a port range here. What this does is it ensures that if we have a particular type of service that requires that that client goes to the same service at all times, it ensures that the same client always goes to the same endpoint server. If we click the Finish button here, that'll actually go through creating this NLB cluster in and amongst the hosts. Now, obviously, we can't create this at this point because, well, this is a mailbox server, and we don't want to create an NLB cluster for a mailbox server. But this is sort of the generic steps that you will want to go through in order to create that NLB cluster for example, a client access server array, or even an edge transport server array. The third server or role that you can say that you may want to configure high availability for is the hub transport server here. Now, what's interesting about the hub transport server is that by default, the hub transport server already has fault tolerance or resiliency built into it, because hub transport servers need to be installed into each individual Active Directory site in your organization. And when you lose a hub transport server, the other servers in the environment will leverage the remaining surviving hub transport servers for the routing of mail until the local site's hub transport server comes back online. What this means is that if your organization has multiple sites, it automatically needs to have multiple hub transport servers, and those servers can take over the roles in the case of the loss of a single hub transport server. Essentially, hub transport servers are very easy. You light them up, you get them ready to go, and they will take care of load balancing amongst themselves and creating that high availability without any extra effort. So these are the mechanisms that you're going to want to be conscious of whenever you're thinking about adding high availability to those non-mailbox servers. Here, let me show you a little picture here that I've created that kind of gives you an idea how you can create full end-to-end high availability across all the different pieces in your environment. Consider out here to the left, you coming in via the internet. And coming in via the internet, you then connect into one of your edge transport servers through an NLB cluster on this location here on the left. Alternatively, you could use a DNS MX record to provide the similar sorts of round robining across these two servers. These two servers at the outset then can connect in with client access servers that are part of an NLB cluster, which then work with hub transport servers in the individual sites, which then therefore work with the individual mailbox servers and the database availability groups you've created on those mailbox servers, so you have multiple copies of those mailboxes. End to end now, you have multiple servers that are supporting all of the different roles, and you can support the loss of any single server in this environment and still have full functionality of your mail. Now, the other topic that we have to talk about here is related to public folders. And as much as Microsoft wants to get rid of public folders, it seems like their customer base really adores their public folders, and they don't really want them to go away. Well, it makes sense because public folders do provide some capabilities for storing data for your users. Here you can see we have our original public folder database, and we've even created a second public folder database here, public folder database 2. Now, these two public folder databases are on individual servers. One is on EX Server or EX Nugget 1, and one is on EX Nugget 2. And we haven't actually created any sense of high availability for these public folder databases as we've created those databases. In order to do that, the location where you'll actually do those replicas and create and configure the replicas is here under the toolbox in the Public Folder Management Console. We've been here before. If we take a look at the Public Folder Management Console, we can see the default public folders. Here you'll see we've created a public folder, My Public Folder, and in here is the parent path, which is essentially the root. If we take a look at the configuration of this public folder, and we choose the properties of it, we will see that we can actually configure the replication of that public folder. What this allows us to do is to replicate the content that's associated with this public folder to another public folder database in our organization. Right now we have my public folder database number 1 that's stored on EX1 Nugget. If I want, I can actually create another replica to my public folder database number 2, which is on EX3 Nugget. What this will do is it will begin replicating the content from one location to the other to ensure that we have the correct content on multiple servers in our environment. We can use the public folder database replication schedule for this, or we can choose to customize our own schedule for when we'll actually go through and replicate content from one location to the other. Be aware down here that the local replica age limit determines how long you're going to actually keep the data in this public folder before it ultimately gets deleted. So this provides a mechanism for us to identify and configure replication across public folder databases. Now obviously, just like with database availability groups, you're going to have to make sure you include all of the necessary design tactics for ensuring you have network connectivity and correct throughput and good bandwidth and enough storage space in the other locations, but at least this provides a location for you to create that sense of replication across the different public folders. Now obviously, as you're going through creating this replication schedule and creating this replication topology in your organization, you may also want to configure how you end up referring your individual clients to the correct public folder. And we can actually do that here within our public folder database, and if we choose the properties here. Now you'll notice we're taking a look at this public folder database. And we've already taken a look at the replication here, which is the replication schedule or interval for that individual public folder database. Also here is the public folder referral. Now we've already taken a look at this in a previous nugget. This really didn't make a lot of sense in that previous nugget because we didn't have multiple public folders out in our organization. But you can see now that we do, we can choose how we want to configure which clients are going to be referred to which public folders. Now by default, clients will be referred to whatever public folder makes sense based off of the Active Directory site costs that are already configured in Active Directory sites and services. Or we can choose a custom list and identify which servers and what costs we want for those individual public folder referrals. This gives us the ability to very discreetly define which clients are going to go to which servers for the public folder information. You may end up wanting to change some of this information here if you need to move around public folders, if you experience a long-term problem with public folders. But really, for most of us, you'll choose to use your Active Directory site costs for those public folder referrals, assuming that you've created those site costs correctly based off of the bandwidth between sites. So what have we talked about in this nugget? We've really focused in on those other non-mailbox servers and the high availability of those non-mailbox servers. We talked about how you can use network load balancing or even a third-party load balancing solution for creating HA for client access servers or for edge transport servers. We talked about how to create round-robin DNS MX records so that you can load balance the incoming mail or the resolution of incoming mail across those edge transport servers. And we talked about that nice and easy high availability that is automatically built into the hub transport server role if you have multiple sites in your organization. We also concluded with a little look here at public folders and how to create public folder replicas and how to set that public folder referral so your clients get to the right replica. I hope this has been informative for you, and I'd like to thank you for viewing.